Hi, this is Alex from devstories.eu, Python, Cheminformatics, and AI, Episode 1 of 22. Before you can predict a drug's toxicity with a machine learning model, you have to solve a fundamental problem. You need a way to teach Python what a molecule actually is. Standard data types like strings and lists do not understand atoms, bonds, or ring structures. To bridge that gap, you need a universal translator between chemistry and code. That is exactly what RDKit provides, introducing the concept of the digital molecule. RDKit is the industry-standard open-source cheminformatics toolkit. At its core, it is a high-performance C++ library, but it exposes a massive intuitive Python interface. It exists because representing chemical structures computationally is surprisingly difficult. A molecule is mathematically a graph. The atoms are nodes, and the chemical bonds are edges connecting those nodes. If you try to build a custom graph parser from scratch every time you want to analyze chemical data, you will spend all your time debugging edge cases. RDKit abstracts that complexity away, managing the graph logic under the hood. To get a molecule into Python, you first need a text representation of its structure. The most common format is a smiles string. Smiles uses standard characters to represent chemical connectivity. For example, an isolated carbon atom is simply a capital C. Benzene, which is a 6-carbon ring with alternating double bonds, is written as a lowercase c, the number 1, 4 more lowercase c characters, and a final lowercase c followed by a number 1 to close the ring. Here is the key insight. That smile string is just plain text. To Python, it is indistinguishable from a password or a file path. You cannot calculate molecular weight from a raw string. To do real chemistry, you must convert it into an RDKit molecule object. You handle this by importing the chem module from RDKit. Then you call a specific function designed to create a molecule from a smile string, and you pass your text variable into it. When you pass the benzene smile string to this function, RDKit does a lot of heavy lifting. It parses the text, builds the node and edge graph, assigns bond orders, and validates basic chemical rules like atomic valences. If the string represents a valid molecule, the function returns a molecule object. If you pass it a chemically impossible structure or a typo, the function fails safely. It prints a warning to your console and returns a null object. Because of this, you should always check if your molecule object actually exists before passing it to the next step of your program. Once you hold that validated molecule object in memory, the entire RDKit ecosystem unlocks. You are no longer working with text, you're working with a computable chemical graph. The essential takeaway here is that smile strings are strictly for storage and data transfer, but RDKit molecule objects are for computation. Everything you do in computational chemistry begins with making that conversion. If you would like to help support the show, you can search for devstories.eu on Patreon. It helps us a lot. That's all for this one. Thanks for listening, and keep building.